Welcome back everyone. Today we are going to make a useful chemical called aluminium isopropoxide. The sole reason why we are even making it is to use it in the MPV reduction, in which a ketone is turned into the corresponding alcohol. We might use this reduction to turn benzophenone into diphenylmethanol. You should definitely not try this preparation at home because it uses a very toxic reagent. For today's preparation, 3 moles or about 230 milliliters of 2-propanol, 1 mole or about 28 grams, which represents a small excess of aluminium foil, and 2 grams of highly toxic mercury 2 chloride are needed. To initiate the reaction, some iodine may be used. We used it, but it might not even be needed. As a source of aluminium, we are using foil. Powder would be too reactive, and chunks or granules might be too unreactive. You can take a look at how much aluminium foil we ended up needing. It looks like a lot, but it's only 28 grams. To make the reaction more efficient, the aluminium foil was cut up. This also greatly reduced the volume and made it possible to add all of it to 1 liter round bottom flask. I assumed in the beginning that this would be the worst part of the preparation, but it ended up not being the worst part. Using a glass stir rod, all of the aluminium foil chunks were then added to 1 liter round bottom flask. I didn't plan to film it in the first place, but it looked really shiny, so I decided to. Before continuing, we dropped in a stirfish. The 230 milliliters of isopropanol were weighed out. 230 milliliters are about 240 grams. To make the stirfish drop to the bottom, the flask was swirled around. Under normal conditions, aluminium is always covered with a thin oxide layer. To get rid of the oxide layer, some iodine was added. This might not be necessary, and only using mercuric chloride might also do the job. Mercuric chloride reacts with aluminium to form a small amount of aluminium chloride and mercury. The mercury forms an amalgam with the aluminium. Aluminium on its own would be too unreactive to react with isopropanol. The amalgam exposes fresh aluminium without an oxide layer, and therefore they can react. We started off by only heating. The stirfish wouldn't work anyways because of all of the aluminium. A reflux condenser was placed on top of the round bottom flask, and to keep any moisture out, we also attached a calcium chloride filled drying tube. As the isopropanol begins to boil, the mercuric chloride is going to dissolve in it, and afterwards the amalgam is going to form. The reaction taking place can be seen above. Aluminium reacts with isopropanol to form aluminium isopropoxide and hydrogen. Here you can see the beautiful reaction. As more of the aluminium reacted, I actually ended up turning on the magnetic stirrer, and in the end it looked like this. Nearly all of the aluminium had dissolved, but some isopropanol had boiled off. The hydrogen just carried the isopropanol gas over, and therefore not all of the aluminium ended up reacting. Therefore I added about 10 more milliliters of isopropanol, which was probably the amount that had escaped. It's also possible to just distill it without even adding more isopropanol, but I wanted all of the aluminium to dissolve, so I added more. The heating mantle was turned off, and I first waited for the isopropanol to stop boiling. Afterwards, this apparatus was set up. It's more or less like a short path improvised distillation, which can be used for vacuum distillations. We began heating at low heat at first to try to get rid of as much of the isopropanol as possible, then I pulled a vacuum and it boiled over. To increase the yields, the stuff was transferred back to the boiling flask, and I boiled again until we were left with this. The small flask, which should mostly contain isopropanol, was taken off and switched out for a larger flask. The distillation was continued and a vacuum was applied. Because it boiled over, the waste contained mercury and mercuric chloride, and I added it to my mercury waste. My mercury waste already contains half a kilogram of mercury 2 sulfate and a lot of hydrochloric acid. It doesn't want to really react with the copper that's in there to form elemental mercury, but I'll figure out a way to recover elemental mercury from it. As the vacuum distillation was continued, some more isopropanol was collected, which ended up being discarded too. A second time it boiled so vigorously that stuff boiled over, the flask was cleaned again, and the vacuum distillation was continued until I ended up disconnecting the vacuum and distilling at atmospheric pressure. We ended up with 173 grams, or about 84.7%, of aluminium isopropoxide. Because of the high temperatures, some mercury might have also distilled over, which led to this grey color. The entire apparatus was cleaned using hydrochloric acid, and we also obtained this mercury. All mercury containing waste was added to this container. As this waste contains little to no mercury, it's not worth recycling for me. Aluminium isopropoxide has a melting point of about 130 degrees Celsius. Despite this, it has a tendency to supercool, which means that it stays liquid even below its melting point. And here's what I mean by this. Even after an hour in the freezer, it looks like honey, but it hasn't solidified yet. Even on the next day, it was still a liquid, so we slapped a label on there. I put some of it into this burning dish and it immediately started to solidify. Either it's because it actually solidified or because it reacted with the moisture in the air. We then lit it on fire and it produced this beautiful orange flame with lots and lots of white smoke, which are probably aluminium oxide with a touch of mercury. Once the entire thing has been burned, a lot of white stuff, which is also aluminium oxide, was left in the burning dish. If you liked today's video, make sure to drop me a like, and if you don't want to miss out on further chemistry content like that, make sure to subscribe. I also have to thank all of my Patreons. You guys make it possible to make even bigger and more awesome projects. If you want to become a Patreon, make sure to check the link in the description. Anyways, I wish all of you a nice day. Until next time.